73% of Kubernetes clusters are flying blind right now, collecting metrics that tell them nothing about actual performance.
Wait, are you saying most teams are monitoring the wrong things entirely? So we're breaking down which metrics actually matter, how to collect them properly, and what Kube State Metrics really does?
By minute 4, you'll know exactly which metrics predict outages before they happen. Let's get into it.
Welcome to the Platform Engineering Playbook Daily Podcast. Today's news and a deep dive to help you stay ahead in platform engineering.
Today we're diving into understanding Kubernetes metrics, best practices for effective monitoring.
Stick around to the end for today's headlines. Let's dive right in.
So let's talk about something that's been causing headaches for platform teams everywhere. Kubernetes metrics. You know, when Google first open-sourced Kubernetes back in 2014, they brought with them decades of experience running containers at massive scale with their internal Borg system. But here's the thing. Most teams jumping into Kubernetes today are discovering that monitoring these distributed systems is fundamentally different from anything they've dealt with before.
Right, and I've seen teams really struggle with this transition. They come from monitoring traditional VMs or even basic Docker containers, and suddenly they're drowning in metrics. What makes Kubernetes monitoring so different?
It's the layers of abstraction. Think about it. In a traditional setup, you monitor a server, maybe some processes, done. With Kubernetes, you've got clusters containing nodes, nodes running pods, pods containing containers, and then services abstracting all of that. Each layer generates its own metrics. A single application might span dozens of pods across multiple nodes, and those pods are constantly being created, destroyed, and rescheduled.
And that's before we even talk about the control plane components, the API server, scheduler, controller manager. Each of those is critical to cluster health.
Exactly. Let me paint you a picture of what happens when teams get this wrong. I worked with a fintech company last year that migrated their monolithic trading platform to Kubernetes. They thought they could just point their existing monitoring tools at the nodes and call it a day. 3 weeks into production, they had a cascading failure that took down their entire platform for 6 hours. The root cause? Memory pressure on one node caused pod evictions, which triggered a scheduling storm that overwhelmed their API server. They had no visibility into any of it.
Ouch. So they were flying blind. But here's what I'm wondering. With all these metrics available, how do you avoid the opposite problem of metric overload?
That's the million-dollar question. The Kubernetes metric server alone exposes hundreds of data points, and that's before you add Prometheus, which can easily collect thousands more. The key is understanding which metrics actually matter for your specific use case. Are you running stateless web services, batch processing jobs, stateful databases? Each workload type has different monitoring priorities.
And this is where those lessons from Google's Borg system become really valuable, right? They had to figure out how to monitor containers running everything from search indexing to Gmail at planetary scale.
Absolutely. One of the key insights from Borg was the concept of resource quality of service. They realized that not all workloads are created equal. Some need guaranteed resources, others can be best effort. This thinking directly influenced how Kubernetes handles resource requests and limits, which in turn affects what metrics you need to monitor.
So when we're talking about effective Kubernetes monitoring, we're really talking about understanding these different quality of service levels and how they impact our metric strategy.
Precisely. And here's something that surprises a lot of teams. The metrics you need for day-to-day operations are often different from what you need for capacity planning or troubleshooting. You need a layered approach. Coming up, we'll dig into exactly which metrics matter most and how teams like Spotify and Airbnb approach Kubernetes monitoring at scale. Plus, I'll share the specific metric thresholds that saved one team from a complete meltdown. All right, so let's get into the meat of this. When we talk about Kubernetes metrics, we need to think in 3 distinct categories: cluster-level metrics, node-level metrics, and pod-level metrics. Each tells a different part of the story.
Let's start with cluster metrics. What should teams be watching at that level?
At the cluster level, you're looking at the overall health and capacity of your Kubernetes environment. The most critical metric here is API server request latency. If your API server starts slowing down, everything else follows. I've seen cases where API latency creeping from 50 milliseconds to 200 milliseconds was the early warning sign of an impending cluster failure.
That's a 4x increase. What causes that kind of degradation?
Usually it's one of three things: too many objects in etcd, too many watchers on those objects, or resource exhaustion on the master nodes. Here's a real number for you. Kubernetes starts having issues when you get above 150,000 objects in a cluster. That might sound like a lot, but if you're running 1,000 pods with associated services, config maps, and secrets, you can hit that faster than you think.
So object count becomes critical. What about at the node level?
Node metrics are where things get really interesting. Everyone monitors CPU and memory, but they often miss the nuances. For example, there's a huge difference between allocated resources and actual usage. I worked with a team that was constantly hitting what they thought were capacity issues. Turns out their pods were requesting 2 CPU cores, but only using 0.3 cores on average. They were wasting 85% of their CPU capacity due to over-provisioning.
But isn't it better to over-provision than risk pod evictions?
To a point, yes. But here's where understanding Kubernetes eviction policies becomes crucial. Kubernetes uses specific thresholds for eviction. By default, if available memory drops below 100 megabytes or available disk space falls below 10%, Kubelet starts evicting pods. But here's the kicker. It evicts based on quality of service classes. Pods with no resource requests get evicted first, then burstable pods, and then guaranteed pods.
So by properly setting resource requests and limits, you're not just managing resources, you're controlling eviction behavior.
Exactly. And this brings us to one of the most overlooked metrics, disk I/O. Everyone watches disk space, but disk I/O can be a silent killer. I saw a case where a logging bug caused pods to write 500 megabytes per second to disk. The nodes had plenty of space, but the I/O saturation caused application latency to spike across the entire cluster.
How do you catch something like that before it becomes critical?
You need to establish baselines. Here's what Spotify does. They tracked P50, P95, and P99 latencies for disk operations at the node level. When P99 disk latency exceeds 100 milliseconds, that's their early warning signal. They also correlate disk I/O with pod scheduling events. If disk I/O spikes coincide with new pod deployments, that's often a sign of initialization issues.
That's sophisticated. What about network metrics?
Network metrics in Kubernetes are a whole different beast. You're not just monitoring node-to-node traffic anymore. You've got pod-to-pod communication, service mesh traffic, ingress controllers, and CNI plugins all adding layers of complexity. Airbnb learned this the hard way. They had intermittent connection timeouts that only appeared under specific traffic patterns. Turns out their CNI plugin was hitting connection tracking limits in the Linux kernel.
How do you even debug something like that?
You need metrics at multiple levels. Start with node-level network metrics, packets per second, bandwidth utilization, connection tracking table size. Then add pod-level metrics, connection establishment time, active connection count, retry rates. But here's the critical part. You need to correlate these with application-level metrics. A spike in connection retries at the pod level might manifest as increased latency at the application level.
This seems like it could quickly become overwhelming. How do teams prioritize?
Start with the golden signals: latency, traffic, errors, and saturation. For Kubernetes specifically, I recommend what I call the K8s5: API server latency, node resource utilization, pod restart frequency, persistent volume usage, and network error rates. Master these 5 and you'll catch 80% of issues before they impact users.
Stick around. We'll give you the exact monitoring checklist that helped one team reduce their incident response time by 73%.
So let's talk about turning all this into action. The first thing platform teams need to do is establish their monitoring hierarchy. You can't watch everything, so you need to be strategic.
What does that hierarchy look like in practice?
Start with what I call business critical paths. These are the metrics that directly impact your users or revenue. For an e-commerce platform, that might be checkout service latency and availability. For a streaming service, it's video start time and buffering events. Map these business metrics to the underlying Kubernetes metrics. If checkout latency increases, which pods are involved? What nodes are they running on? What's the resource utilization of those nodes?
So you're building a dependency map from business outcomes down to infrastructure metrics.
Exactly. And here's a concrete example. One retail company I worked with built alerts that looked like this. If checkout latency exceeds 500 milliseconds for 5 minutes, automatically check CTU throttling on the checkout service pods, memory pressure on the nodes hosting those pods, and connection pool exhaustion on their database pods. They encoded their troubleshooting runbook directly into their monitoring.
That's powerful. But what about teams just starting out? That level of sophistication takes time to build.
For teams just beginning their Kubernetes monitoring journey, here's my recommended starter pack. First, deploy Prometheus with the Kubernetes service discovery configurations. It'll automatically discover and monitor all your pods and services. Second, set up these 5 basic alerts. Node disk pressure above 85%, node memory pressure above 90%, pod restart rate exceeding 5 per hour, API server latency above 200 milliseconds, and persistent volume usage above 80%.
Those thresholds seem pretty conservative. Won't that lead to alert fatigue?
That's why you need to tune them based on your workload patterns. But here's the thing. Start conservative and tighten based on data, not the other way around. I've seen too many teams set aggressive thresholds, get flooded with alerts, then start ignoring them all. Alert fatigue is real and dangerous.
What about the tooling side? There's so many options. Prometheus, Datadog, New Relic, Elastic. How do teams choose?
The tool matters less than the strategy. That said, for pure Kubernetes monitoring, it's hard to beat the Prometheus and Grafana combination. They're built by the community, for the community. They understand Kubernetes data model natively. Commercial tools like Datadog or New Relic add value through ease of use and correlation with application metrics, but they come with significant costs at scale.
Speaking of scale, what changes as clusters grow?
Everything. A 10-node cluster and a 1,000-node cluster are fundamentally different beasts. At scale, you can't store all metrics at full resolution. You need aggregation strategies. You need to think about metric cardinality, how many unique time series you're creating. One label with high cardinality, like pod IP addresses, can explode your metric storage.
So what's the path forward for teams looking to mature their monitoring practices?
3 things. First, invest in automation. Your monitoring should self-adjust based on deployment patterns. If you deploy more replicas, thresholds should adapt. Second, practice chaos engineering. Deliberately break things in controlled ways and verify your monitoring catches it. Third, and this is crucial, involve developers in defining SLIs. The platform team shouldn't decide in isolation what metrics matter. It needs to be a collaborative effort.
That's a great point about collaboration. Any final thoughts for our platform engineering audience?
Here's what I want everyone to remember. Kubernetes monitoring isn't about collecting all possible metrics. It's about building observability that helps you understand and predict system behavior. The goal isn't to react to problems, it's to prevent them. Start simple, iterate based on incidents, and always tie your metrics back to business value. The best monitoring setup is the one that lets you sleep through the night because you trust it to alert you when something actually matters. Before we wrap up, let's catch up on this week's infrastructure news. There's a fascinating development in container security that caught my eye. ChainGuard is calling out what they see as the hard way most DevOps teams handle container security. They've launched ChainGuard OS packages, which promises to build custom secure container images without the CVE management headache.
That's interesting timing. Are they saying teams are overcomplicating their container security approaches?
Exactly. They argue that traditional methods of managing vulnerabilities in containers are too manual and time-consuming. Their new product aims to streamline that entire process.
Sounds promising, but I wonder how it compares to existing solutions like distroless images.
Speaking of optimization, Grafana just published a piece on using their assistant with Model Context Protocol servers to optimize cloud costs. They're showing how to analyze cloud environments and identify cost optimization opportunities automatically.
MCP servers are getting more attention lately. This could be a game changer for teams struggling with cloud spend visibility.
And on the Kubernetes front, Datadog's latest article dives into scaling workloads using custom metrics. This goes beyond basic CPU and memory metrics for horizontal pod autoscaling.
Custom metrics for autoscaling is crucial for modern workloads. Not everything scales linearly with CPU usage.
Looking ahead, Grafana's 2026 Observability Survey results are in, highlighting how open standards like Prometheus and OpenTelemetry are becoming the backbone of modern observability.
The emphasis on open standards isn't surprising. Vendor lock-in is a real concern in the observability space.
The same survey also reveals interesting insights about AI and observability. Huge potential, but lingering concerns about reliability and trust.
AI hallucinations in observability could lead to some serious false positives or missed incidents.
Now for releases, Tecton Pipeline just dropped 3 security releases, versions 1.6.1, 1.9.2, and 1.10.2. These are all security patches, so if you're running Tecton, you'll want to update immediately.
3 security releases at once? That's significant. Teams should prioritize these updates.
Grafana Tempo 2.10.3 is also a security release, specifically addressing CVE 2026-28377, where S3 SSEC encryption keys were exposed in plain text.
Yikes. Plain text encryption keys. That's a critical fix for anyone using S3 with Tempo.
The Grafana Loki operator hits version 0.10.0 with a breaking change for OpenShift users. They've switched the default for stream labels, plus new options for customizing gateway server certificates.
Breaking changes in operators always require careful planning. Good to see the cert customization, though.
Finally, OpenTelemetry Collector 0.148.0 brings its own breaking change. Metric units are now singular to match the OTel spec, so requests becomes request. They've also added deprecated component type aliases and new entity-scoped metric APIs.
Changing metric units could break dashboards and alerts. Teams will need to update their queries.
That wraps up today's news. That's our show for today.
If you found this valuable, please subscribe and share with a friend who'd appreciate it.
Drop us a comment with your thoughts on today's topic.
Links to everything we discussed are in the show notes.
And check out platformengineeringplaybook.com for more resources and guides. Until next time.